Hello friends, how are you? I'm Shmal Stasharma from Ethiopia. I'm a medical microbiology student. I'm going to discuss about multidrug-resistant Candida species. Invasive Candida species infection is a major source of morbidity and mortality in healthcare settings. There are at least 50 different Candida species that cause human illnesses. From this, around 90% of invasive diseases related to these 5 Candida species. It could be either Candida albicans, Candida glabrata, Candida tropicalis, Candida parapsilosis, and Candida krusei. Each of these species has its own virulence potential, antifungal susceptibility, and epidemiology. And severe infection caused by this organism are commonly referred to as invasive candidiasis. When we see the multidrug resistance definition and the limitation of this multidrug resistance have its own definition and a limitation in fungi world. So standard definition of multidrug resistance, extended drug resistance, and pan-drug resistance for bacteria established by European CDC or CDC cannot be used in regards to fungi. For example, multidrug resistance is acquired non-susceptibility to at least one agent in 3 or more antimicrobial categories when we see in case of fungi. Extended drug resistance is non-susceptibility to at least one agent in all but 2 or few antimicrobial categories. When we see pan-drug resistance, non-susceptibility to all agents in all antimicrobial categories. And this definition cannot be directly adopted for resistance in fungi, for example, Candida. Only 4 classes of drugs are available. Sorry, this one is for bacteria, but for fungi, when we see only for a Candida example, only 4 class of drugs are available, that are azole, pollens, and echinocandins and phyllocitosins. So MDR in fungi means as an isolated non-susceptible to greater than one agent in greater than 2 drug classes. And XDR in fungi is as an isolated non-susceptible to greater than one agent in greater than 3 drug classes. This is the definition that we had. When we see these drugs, for example, azoles, pollens, and echinocandins are licensed for monotherapy against Candida infection, and these echinocandins and phyllocitosins are recommended as first-line drug agents for invasive candidiasis. Epidemiologies and drivers of resistance for fungi, invasive fungal infection are, for example, being a cancer patient, AIDS patient, and organ transplant recipients, premature infants. Mostly fungi infection are largely caused by a threat to immunocompromisation to individuals. Reports of fungal agents rates are relatively low when compared to antimicrobial resistance, but have become considerably more prevalent since the introduction of additional antifungal drug, particularly azole, that is mainly fluconazole, which is widely used against Candida infection due to the AIDS patients. For example, in AIDS patients, this fluconazole is given as prophylaxis because to prevent the invasion of Candida. Antifungal resistance could be either intrinsic or acquired. When we see intrinsic resistance, intrinsic or primary resistance is inherent resistance. For example, this inherent resistance could be resistance of Candida krusei for fluconazole, because Candida krusei is not naturally susceptible to this Candida krusei, and resistance of Candida auris for several class of antifungal drugs also. That means Candida krusei is naturally resistant to several class of antifungal drugs also. When you see acquired resistance, this is developed through exposure of antifungal treatment without a prior intrinsic resistance pattern. That means this fungus doesn't have naturally resistance to these antibiotics, but throughout the exposure of these antifungals, this fungi or this Candida species develops resistance to this antifungal agent. Overall antifungal misuse in agriculture and the medical. This acquired resistance could be due to overall antifungal misuse in agriculture and the medical care, or therapeutic drug level use in medical care, or drug sequestration in biofilm matrix due to waste disposal system or some kind of areas. And the other is due to mutation. This is mutation could be because of DNA mismatch repair gene mutation, also which facilitates the acquisition of resistance. When we see molecular mechanism of resistance, for example, the amphotericin B drug target is ergosterol, and target gene mutation for resistance is ergosterol gene 2, 3, 5, 6, and 11. That makes less ergosterol formation. So this drug decreases ergosterol formation. So mutation on this gene this drug acts on ergosterol, so the mutation on these genes will initiate the less ergosterol formation. So this drug doesn't have any drug target, so this drug could be useless in this case. And echinocandins, their drug target is glucan synthase, and mutation on these target genes will make less binding site for this drug, so this drug doesn't have an effect if these genes are get mutation. And the other is azoles. The drug target for azole is P450 dimethylase. So this drug target is coded by ergosterol gene 11. So the mutation on this drug target gene will cause less formation, less binding site for this drug. That means there will be less formation of this P450 dimethylase, so this drug cannot bind in that case. The other is target upregulation. For example, UPC2 isochromosome. This abnormality could lead to drug upregulation. That means the upregulation of this gene will lead to the mutation. And the other is CDR, and these two targets. This make an efflux pump on the fungal cell, so the drug that enters to the fungal cell will be effluxed through this pumps also. And azole resistance could be either by target gene mutation or target gene upregulation. Target upregulation and efflux pump formation. The other is flow cytosine. This flow cytosine target is DNA and RNA synthase. The resistance for this drug could be by loss of primase and reduced intracellular activation by these genes. Multi-resistant Candida species until a few years ago that multi-resistance had been used scarcely in the literature. There is a few case reports of fungal MDR infections, but recently with widespread misuse of echinocandins in different regions, for example, as a prophylaxis, empirical treatment, and the target gene therapy, this reality has changed dramatically. So we are facing now an increased number of invasive infection caused by Candida albicans and non-Candida albicans MDR species, for example, Candida glabrata, Candida krusei, and Candida auris, mostly isolated MDR non-albican Candida species. Most MDR Candida infections are caused by isolates from species that have inherent resistance, such as echinocandin resistance in Candida glabrata and Candida krusei, or infection with Candida krusei, which is inherently resistant to multidrugs and is currently emerging. This multidrug resistance is uncommon in species that lack intrinsic resistance. However, in Candida albicans and the Candida dubelensis, ergosterol gene 3 and ergosterol gene 2 mutation have been linked to azole and amphotericin B resistance, respectively. Resistance to azole and pollens have been seen in Candida isolate with ergosterol gene 11 mutation in combination with either ergosterol 3 or ergosterol 5. It could be in combination with these two genes or with only ergosterol 11 mutation. Despite its multidrug resistance, Candida auris has already spread to a number of countries across 4 continents. For example, echinocandins are the major therapeutic choices for Candida auris. However, pan-resistance isolates have been reported. Multidrug resistance, high mortality rate, horizontal transmission, and the environmental persistence. These cases make it particular global concern and a major problem for infection control of this species, this Candida auris. When we see multidrug resistant Candida species in Ethiopia, there is a report of multidrug resistant Candida albicans, which is resistant to azole and the pollen drugs. There is also a report that shows 11 to 32% of azole resistant Candida species to one or more antifungal agents. That means azole group. But there was reported no resistance. There was no reported resistance to amphotericin B. This is also a report of intrinsic resistance Candida krusei. There is also resistance report of intrinsic resistance to Candida krusei in Ethiopia, but there is limited information regarding its multidrug resistance status. As a conclusion, MDR Candida species has become increasingly important in management of invasive fungal infections. These infections are associated with high morbidity and death rates, and they can be transmitted through healthcare setting. And the emergence of MDR Candida glabrata has widespread in many medical facilities, posing substantial management challenge. Similarly, Candida auris has emerged as a significant clonally distributed species. This one is to say globally distributed species exhibiting MDR and XDR features, as well as long-term colonization and extensive environmental contamination. With this resistant infection, the outcome are poor and consequently a precise mycological diagnosis and medication guided by susceptibility testing should be performed to maximize care. Thank you, and I will see you next time.